Hi, I'm Maggie. Have you ever wanted to detect a low copy number DNA template in your sample or needed to accurately quantitate a gene's expression level? If so, you may consider using quantitative PCR. PCR is an important tool in many molecular biology labs where it is used to amplify DNA or RNA fragments and detect nucleic acid sequences within a sample. In traditional or endpoint PCR, the amplification product is detected after the reaction is complete. For some applications, endpoint PCR is acceptable for qualitative nucleic acid detection or the presence or absence of a gene in a sample. However, many applications require more sensitive quantitative analysis. Real-time or quantitative PCR methods detect and measure the accumulation of PCR product as amplification proceeds. If the sequence being amplified is abundant in the sample, the qPCR product is detected early in amplification. If the sequence is rare, then the product isn't detected until later. This allows for a high level of sensitivity and wide dynamic range, resulting in accurate quantitation. qPCR can be used to study gene expression, evaluate a sample's genotype, and to study copy number variation. It is a technique that can provide a lot of information on a sample in a short period of time. So, how does real-time PCR detection work? The amplification is detected by measuring a change in a fluorescent reporter signal. So, one of the critical components in real-time PCR is this fluorescent reporter. The reporter is a part of the reaction mix, and there are two general types of reporters that are used. One type of chemistry is a dye-based detection method, where a fluorescent binding dye is used that is specific to double-stranded DNA. Alternatively, probe-based detection method can be used, which would utilize a primer or probe that is labeled with a fluorescent reporter. For a more in-depth review of dyed and probe chemistries, or 1- and 2-step RT-qPCR, please see our qPCR Chalk Talks at premiga.com/discoverqPCR.